What is going on, guys? It's Bucky and welcome to your 30-second chemistry tutorial, and in this tutorial we're going to start talking about chemical reactions. Now chemical reactions are a little bit different than nuclear reactions in the sense that we aren't messing with the nucleus at all. We aren't changing any of the elements themselves, we're just changing how they are bonded together basically. So this is pretty cool in the sense that we can't make any bombs really, but we can make new types of fuels, drugs, medicines. That's what they typically use these for. So let's go ahead and start with, well, I guess I might as well say this before I begin. The process whenever I write this is still the same as a nuclear reaction. We start with the reactants and we draw our little arrow. That's a terrible arrow right there. Could give a nice sharp point, and we end up with products. So pretty much the reactants are what you start out with, and the products are what you get at the end. And another thing that was, I don't even know if I talked about this whenever I was talking about nuclear reactions, but I also have something called the coefficient. Now, if you have something like 2CO2, this thing right here, this 2, is called the coefficient. Now, the coefficient pretty much means how much of each molecule there is. For example, the difference between CO2 and 2CO2, if you just write CO2, this would mean you would have one carbon and two oxygens. However, if you wrote 2 CO2, it would mean you have two of this. So in other words, you would have two carbons and four oxygens. You see how that works? So anyways, if you don't see, then once I do a couple examples, then you guys are going to know what I'm talking about. So let's go ahead and start with a couple terms that I'm going to be saying, thrown around a couple times. So I might as well explain to you guys what they mean right here. Exothermic is a reaction where heat is given off. One of the products is heat. Now endothermic is when heat is absorbed. For example, you may have to add heat to get a chemical reaction started, and it absorbs some of that heat. Now, activation energy, as we can see, the amount of energy you need to start the reaction. And this is because in order for chemicals to react, they need to bump into each other. You can't just have some carbon in Rhode Island and some oxygen in Texas and expect them to form a chemical reaction. The molecules actually need to collide with each other so they can break each other's bonds, form new bonds, and all that good stuff. So heat or activation energy or kinetic energy can make this happen because whenever you have heat, stuff starts moving around, bumping into each other, and once they hit each other, once they collide, they can break each other's bonds, and that's what starts the chemical reaction. Now, another thing I want to mention is that aside from just having the energy, the molecules must also hit each other in the right spots. For example, say that you have some, I'm not even gonna, make a molecule. I'm just gonna put like, if you had a molecule 2 and a molecule 3 and they were bonded together. Now this molecule 1 was gonna come in and react with this thing right here. Well, it needs to collide in just the right spot. For example, it could go ahead and hit number 2, and whenever it did hit number 2, there may be a reaction. However, if it hit, I don't know, let's say if it hit number 3 right here, there would be no reaction. So aside from just that initial energy, you also need the molecules to hit in just the right spots in order for a chemical reaction to take place. So there are actually a bunch of different types of chemical reactions, and I'm going to be talking you guys through all the different types of reactions, and I'm going to start with something called a combination reaction. Now this is arguably the most simple chemical reaction. All it is you take two or more reactants or starting stuff and it forms a single product. So pretty much you're combining two different things in order to form a single thing. Pretty weird, huh? So let's go ahead and take a look at an example. Say you have 2H2 and you combine it with O2. What you can form, let me go ahead and fix my arrow, is two molecules of water. Now remember I talked to you guys about the coefficients, and I'll talk to you guys about balancing a chemical equation later on, which pretty much means make sure you have the same amount of stuff on this side as on this side. But if you guys just cannot wait, then I'll go ahead and talk you guys through it. So we already know that H2O is water, and this is hydrogen, and this is oxygen. so I don't need to, tell you guys what we're making here. But in order to make sure that this is, a sensible chemical reaction that is actually valid, we need to go ahead and balance this. So what we do is we make sure that all of the molecules on the left-hand side equal the sum of all the molecules on the right-hand side. We just can't start with like 6 hydrogens and 8 oxygen and end up with like 2 hydrogen and 27 oxygen. We can't destroy or create stuff. It needs to be balanced on the left and right hand side. So in order to do that, remember, 2H2 pretty much means 2 of these H2. In other words, H4. We got 4 atoms of hydrogen. Now there's no coefficient on the O2, which means we just have 2 atoms of oxygen. Now, if we go ahead and take a look at the final product, we have 2H2O, which pretty much means we have 2H2, so H4, 4 atoms of hydrogen, and 2 oxygen. Remember, if there's no number written here, it's just implied that there's a 1. So we pretty much have 2 oxygen atoms. So when we look at the final, it says we have 4 hydrogen, 2 oxygen, 2 oxygen. There we go. So now let me go ahead and show you guys one more quick, what color did I not use? Haven't used red yet. So let me go ahead and show you guys one more quick example. Again, I told you guys about balancing chemical reactions real quick. We're going to be talking about it more later on whenever we get to really weird chemical reactions. But for now, we're just talking about combination reactions. How we can start with 2 things and they can combine to form one thing. In this example, 2 molecules of water, H2O. So say we have 2 sulfur atoms, so 2S. Now 2 sulfur atoms can combine with 3 O2 molecules, and O2 is just it's pretty much 2 oxygens bonded together, and this could form 2SO3. Now SO3 is sulfur trioxide, and if we go ahead and balance the reaction real quick, we can see that, okay, we have 2S, which pretty much means we have 2 sulfur atoms. We have 3 O2, which pretty much means we have 6 oxygen atoms. And on this side, we have 2S, and remember, when there's no subscript here, it just implied that there's 1. So we have 2 sulfur, and we have 2, pretty much, this is 3 oxygen atoms bonded together, and we have 2 of them. So in other words, we have 6 total oxygen atoms. So if we go ahead and look on the left side, 2 sulfur, and on, again, the left side, 6 oxygens, and on the right side, 6 oxygens. So we're good to go, and that's the basics beyond, balancing chemical reactions. It should be pretty self-explanatory. I probably didn't even need to talk you guys through it, but if you guys were lost and didn't understand the difference between a coefficient and a subscript, then there you go. So anyways, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial where we're going to be talking about all the different types of chemical reactions. There are a lot more aside from combination reactions. So that's what you have to look forward to. Thank you guys for watching, and I will see you guys later.